Moving on to page 3 of composite shapes here. More sort of applications of how we can use these shapes to solve problems. Okay, remember the idea of composite shapes is we have a large shape composed of some smaller shapes. If I look at this first example here, I want to find the area of this shape, and I take a look at that, and I could draw a line sort of down here to break this into two parts. I have shape number 1, sort of a half a circle, and shape number 2 would be a rectangle. Those are basic shapes, things I can deal with. If I take my circle idea, pi r squared, that would be a whole circle, but I only want half of that, so I'm going to divide by 2. The radius of that circle, half the distance, this line here I just drew is sort of the diameter, right? And we know that's 3 from the other side of the rectangle. So half of that would be 1.5 squared. Again, don't forget to divide by 2. That's one of those common mistakes people make. If I calculate that, I end up with 3.53 centimeters squared. And that's one of my two shapes. My second shape is a little bit simpler. It's a rectangle, length and width. We know it's 4 by 3, so that's 12. If I want to know the area of this entire shape, the total area, if you will, I can take my first shape, the half circle, and my second shape, the rectangle, and add them together, and I know the total area will be 15.53 centimeters squared. I was able to recognize smaller shapes in this overall bigger shape. Maybe pause the video, try the second one yourself, see how you can do with that. If not, I will take you through it. Okay, so looking at this shape, I'm going to call the triangle at the top here shape 1, and the parallelogram shape 2. So my triangle is base times height divided by 2. My base and height has to be meeting at a 90. I think of this as the 90. The base of that, because it's a parallelogram on the bottom, the 6 matches the top and the bottom. My base. My height, while looking at this diagram of these two little dashes here, I know the entire distance is 20. So in my case, these are each 10s. And I want to divide that by 2 because it's the triangle. I end up with 30 centimeters squared. There's my top shape, the triangle, area number 1. Area number 2 would be a parallelogram, which we know is base times height. They have to be meeting at a 90. Good news is I've got a 90 right here. My base would be 6. My height would be 10. That shape would be 60 centimeters squared. Which means when I go to the total of this one, I can add 30 and 60 and get a total area of 90 centimeters squared. Okay. Again, the trick is recognizing smaller, simpler shapes within an overall larger, more complicated shape. Example number 2 on the back page, we're looking for the shaded region in this figure. The shaded region is these little bits and pieces on the outside of the circle, but inside the square. If we take those two ideas, okay, the outside of one shape is the inside of another shape, we can take the square and subtract the circle, and I'll be left with all those small little bits and pieces. Okay, a square, think of it as a rectangle if you want to, a length times width, or the length squared, because it's the same thing twice, minus my circle, pi r squared. Again, be careful here because radius. And if you subtract those two areas, you'll get the area of the little bits and pieces in between. So my square would be 12 squared, and I'm going to subtract, and you can do this in two parts if you want to, and then subtract later, or do it all at one time if you want to. Pi times the radius. Our radius would be from the center out, so that would be 6 squared. Okay, my square is 144. My circle, pi times 6 squared is 113.1. And if I subtract the circle from the square, I end up with 30.9 meters squared. That's those little bits and pieces we otherwise would not be able to figure out without taking the outside minus the inside. And the last one, a little bit of problem solving. Give it a try. Pause the video and see if you can figure out what's going on here and see if you get the right answer. And then you can try some of the homework afterwards. We have Chris. He's got a square garden. We know the area of this square garden is 38.4 meters squared. But we don't know the size of it. All we know is he wants to make a smaller garden. He wants to decrease the size of each of his sides by 1.7 to make this new garden. And he wants to know the perimeter of that thing. Well, to know that, I kind of need to know the sides of the original one. The key here is that it's a square. The length of one side and the length of the other side are both the same. In other words, when I talk about a rectangle being length times width, or a square being length times length, length squared, it allows me to solve this problem. Okay, I know the area is 38.4. That's my length squared. So to find my length, I can square root that. And I'll end up with 6.2. Okay, and that's our original size. Each of these is 6.2. And if you want to check it, you can try. 6.2 times 6.2 comes up to 38.4. His new garden, he wants to take each of the original sides and subtract 1.7 from them. So for this side here, 6.2 minus 1.7 gives us 4.5 meters. So again, it's a square, so 4.5 meters for each of them will allow us to find the perimeter of our new garden. We can do 4.5 4 times, add it up 4 times, or just simply multiply it by 4, and you'll get his new garden being 18 meters. That takes us to the end of the second lesson, composite shapes. This is a little bit of a longer lesson, probably one of the longer lessons you're going to see this year just because there's so many little ideas in there. Try the homework. I did not put a quiz up for this one, just because I want you to practice the homework. But for the next couple of days, I'll try and put some quizzes up so you can check to see how you are doing with each of those.